Welcome to our lesson today. My name is Purity Anzelimo, and our topic for today is differentiation. Differentiation. That's our topic today, differentiation. And before we look at what we are going to look at this lesson, I would just like to do a recap. I summarize what we covered during the previous lesson, whereby we were looking at finding the gradient function. Gradient function. We were looking at how to find the gradient function, which we also said is referred to as the derivative, which we also refer to as the derivative. And we say that this process of obtaining this function, the gradient function of the derivative, is what we refer to as differentiation. Differentiation. And therefore, when you are told to differentiate, and for example, you are given the equation of the curve, for example, in this case, y is equal to x raised to power 3, and you are told to differentiate, simply meaning find the gradient function or find the derivative. We simply come and find the derivative, that is dy all over dx, which is equal to, you remember the formula for finding the gradient function dy all over dx, which we said is nx n minus 1. So in this case, we take this power, the power of x, we multiply by the coefficient of x. In our case here, the coefficient of x is 1. When we have 1, we don't need even to write it, because 1 multiplied by a number is equal to the number. So the coefficient here is 1. So we multiply 3 by 1. So we have 3. Then we have x. Then this power, we subtract 1. So we have 3, we subtract 1. I repeat, you need to multiply the power by the coefficient of x, which in our case is 1. So 1 times 3 will have 3. Then we have x. Then the power, we subtract 1. So we are going to have 3x raised to power 2. And that is the derivative of the equation y is equal to x cubed. Again, we can have another equation whereby y is equal to 3x power 4. 3x power 4. Now, in this again, when we want to find the dy dx, again, we need to multiply the power of x, we multiply by the coefficient of x. In our case here, the coefficient of x is 3. So we take 4, we multiply by 3. So we can simply write it this way, we write 3, so we are multiplying by 4, 3 times 4. And then we have x, then power minus 1. As we can see here, power minus 1. So we have 4 minus 1. So we end up getting this as, we have 3 times 4, that is 12. Then we have x raised to power 4 minus 1, which is equal to 3. And that is the derivative of the equation y is equal to x raised to power 4. So this coefficient can either be 1, it can be 1, it can even be a negative number, negative 4, it can even be a fraction, maybe negative even a half, 3 over 4. It can be any number, negative, positive, it can be also a fraction or a whole number. For example, when you have an equation like this, y is equal to negative 3 over 4x raised to power 4. So when you have that again and you want to find the derivative, which is dy all over dx, again in this, the first thing is to multiply the power of x, we multiply it by the coefficient of x. And the coefficient of x here is negative 3 over 4. So we are going to have negative 3 over 4, we are multiplying by 4, which is the power of x. Then we have x, then we have 4, the same power, we subtract 1. So we are going to have negative 3 over 4. We multiply by 4x raised to power 4 minus 1, that is 3. So we have negative 3 over 4 times 4 by 4, 1 by 4, 1. So we end up getting negative 3x raised to power 3. So you follow the process. You start by multiplying the power of x. You multiply it by the coefficient of x. Then after multiplying, you have the x. Then the same power, you subtract 1. Again, you can have maybe the last one. Y is equal to, for example, let's say negative a half x. Negative a half x. So in our case here, you need first to get the power of x. In our case, when we have a number like, when we have a number, or maybe we have a number like 3, the power is 1, because any number raised to power 1 is equal to the number. So here the power is 1. It is the same. If we don't have here, it simply means y is equal to negative a half x raised to power 1. So we need to multiply the power by the coefficient of x. And because the power here is 1, we have 1, we multiply by negative a half, so that we can get the dy dx. So we are going to have 1 multiplied by negative 1 over 2. That will be negative 1 over 2. We are multiplying by 1, so it still remains. Then we have x, and we have the same power minus 1. And we'll end up getting negative a half x raised to power 1 minus 1, that is 0. And therefore, from the law of indices, we know that therefore any number raised to power 0 is equal to 1. And therefore, this x raised to power 0 is 1. And therefore, dy all over dx will therefore be equal to negative a half. That will be the derivative. So note that differentiation, that is finding the gradient, or simply the gradient function, or the derivative, the formula, multiply the power by the coefficient of x. Sometimes it must not be x. We have done examples whereby it is y is not a function of x. We can have now another, maybe y, which is a function of another letter. So you multiply the power by the coefficient of whatever you have, either x, b, or whichever letter. Then after that, you have the x, then the same power minus 1. And therefore, we concluded that the general formula for finding dy dx is simply nx n minus 1. And that's what we have in differentiation. So today, I want us to look at, in this lesson, I want us to look at the equations of tangents, and the normals, equations of tangents and normals to a curve, equations of tangents and normals to a curve. So we have to, we'll be looking at these two types of equations, that is equations of the tangents to a curve, and also the equations of normals to a curve. And we are going to start with the tangents. We'll start with the equations of tangents. The equations of tangents. Now, when we have a curve, for example, a curve like this one, and we want to find the gradient at a point, and gradient at a certain point, let's say at a point, we can call this one point P. When we want to get the gradient at point P, we need to draw what we refer to as a tangent. A tangent is a line that will pass through that point. It is a straight line. When we talk of a tangent is simply a straight line that will pass through the point given, that will pass through the given point, such that if we want to draw the tangent to this point here, because we want to get the slope or the gradient function of this curve, this is the curve, This is our curve. We want to get the gradient of the curve at point P. And therefore, you just come and draw a straight line that will only pass through that given point. So that will pass the horizontal line passing through that point only. So we have it this way. And therefore, this is our tangent. We can call this our tangent. This is the tangent. So when we want to find the gradient of the curve at point P, the gradient of the curve at point P, we simply come and get the tangent, and then we find the gradient of the tangent. So gradient of the curve at point P is equal to the gradient of the tangent. The gradient of the tangent. So by getting the gradient of this tangent, we'll be in a position therefore to get the gradient of the curve at that point P. So can do some examples on how to calculate the equation, how fast we can get the gradient, then we get the equation of the tangent to a curve, equation of the tangent to a curve that is at a certain point. So we have seen that when we are getting the equation of a tangent, we need first to get the gradient. And for us to get the gradient of the curve at the point, we need to draw the tangent, which is a straight line passing through the given point only once at that point. So the gradient of the curve at this point P is equal to the gradient of the tangent. And therefore, we want to know how we can get the equation of a tangent to a curve when we are given an equation. So like in this example here, we are told find the equation of the tangent, find the equation of the tangent to the curve. We have been given the curve y is equal to x cubed plus 2x plus 1 at the point 1, 4. So those are the points, that is the point that we have been given, and we are told to find the equation of the tangent to the curve. This is the equation of the curve at point 1, 4. This is the coordinate of that point. Just like we can have a point here which is point P here. So our point P is 1, 4 at a point 1, 4. So we have to find now the equation, and before we get the equation, for us to get an equation of the line, because it is a straight line, it is an equation of a straight line because it is a tangent, the equation, we need first to get the gradient. We need first to get the gradient of the tangent. The gradient of the tangent. That should be the first thing. We need to calculate the gradient of the tangent. And therefore, we have the equation of the curve. Y is equal to x cubed plus 2x plus 1. So when we want to find the gradient, we first get the gradient function dy dx. That will give us the gradient. So we need to differentiate this, or to find the gradient function. So we have 3 multiplied by the coefficient of x, which is 1. So we'll have 3x. Then we have 3 minus 1. Then plus x here is raised to power 1. So we have 1 times the coefficient, which is 2, x 1 minus 1. And then this is a constant. And we say that the gradient function of a constant is 0. So we have a 0 here plus 0. So our dy dx will be 3x squared, then plus 2x raised to power 1 minus 1 is 0. And therefore this one becomes 1. So we are going to have plus 2. So that is the gradient function. And we are told it is at 0.14. So this is the value for x, and this is for y. So we have dy all over dx, which is equal to this. And therefore, we need to calculate now the actual gradient, the gradient, so that we can use now the points. So we have that dy all over dx is equal to 3x squared plus 2. So we can get the gradient because we have the point at point 1, 4. So we have xy. So we can come substitute the values of x with 1. So we are going to have our dy all over dx, which is our gradient, to be equal to 3. Our x is 1, so we have 1 squared, then plus 2. So we are going to have 3 times 1 plus 2, that is 5. So our gradient is 5. So that is the gradient of the curve at that point, 1, 4. So we can simply come and say that our m, which is the gradient, is equal to 5. And we have the point we have is 1, 4. So we need to come and get the equation. From the equations of a straight line, when we want to get the equation of this tangent, because it's like we have the curve here, and then we have our point, and this point we have the tangent here. This is our tangent, and we have this point. Let's say here we have a point 1, 4. So we can come and get another point on the tangent. We can call it xy. So we are going to have point 1, 4 and another point xy. And we know that the gradient is equal to 5. And we know gradient m is given by change in y divided by the change in x. So in this, we are going to have the change in y, which is y minus 4. So we have y minus 4 all over the change in x, which is x minus 1, is equal to the gradient, which is 5. A whole number is always over 1. Then we can close multiply so that we can get the equation. So in this case, we are going to have it this way. So when we close multiply, we have y minus 4. We are multiplying all of it by 1 is equal to x minus 1. We are multiplying that by 5. So we end up getting y minus 1 is equal to, we open the bracket, 5 times x, we have 5x. Negative 1 times 5, we have minus 5. And therefore, we have, this is what we have for the equation of the tangent. And the tangent is a straight line, so we expect the equation to have the form of equation of a straight line. So we have y minus 1 is equal to 5x minus 5. So we can write it in the form y is equal to mx plus c, which is the equation. This is the equation of a straight line. So we'll simply come and say we have here y is equal to 5x minus 5. Then we take 1 to the other side, we have plus 1. So y is equal to 5x, then minus 4. And this is the equation of the tangent. This is the equation of the tangent at the point 1, 4. And we can see clearly from this equation, we can see clearly that y is equal to 5x minus 4. This is an equation of a straight line. And we know that the general form of an equation of a straight line is equal to y is equal to mx plus c. Meaning that this is our gradient. And we can see clearly that our gradient is 5. And there's somewhere where we calculated the gradient as 5. So we can confirm that it's okay. So, and the y-intercept, it will pass through negative 4. So this is the equation of the tangent. So I repeat, whenever you are given such, find the equation of the tangent to the curve. This is the curve at this point. The first thing is to get the gradient function. The gradient, so the gradient function, and our gradient function, we simply differentiate. So when you differentiate, you get the gradient function. Then after getting the gradient function, we require to get the actual gradient at the point 1, 4. And therefore, since we have this is the gradient, therefore, and we have 0.14, for x we have 1. So we come and substitute x with 1. So we are going to have the gradient as 5. Number that is 5. Then after getting the gradient and we have the point, we can now come and get the equation. Because we know when we have the point, we get another imaginary point xy. We have the gradient that is 5. And therefore, gradient is change in y all over change in x. And therefore, our change in y, we have y minus 4. So this xy is an imaginary point. It is another point on the tangent. It can be on this side, on whichever the side. So it is a point again on the tangent. So we know very well that gradient m is given by change in y all over change in x. Our gradient is 5. Then we have change in y, y minus 4 divided by x minus 1. Then we can close multiply and get the equation in the form y is equal to mx plus c, which is the general equation of a straight line. And therefore, our equation for the tangent is equal to y is equal to 5x minus 4. And that is the equation of the tangent. I would like us to do another example. We are still in tangents. We are finding the equations of tangents to a curve. We are still in tangents. So we have another example. Example 2. We are told find, the question is find the equation of the tangent, find the equation of the tangent to the given curve, at the indicated point, at the indicated point. So we have the first one, y is equal to x cubed plus x squared plus 1, and the point is 1, 3. So we want to find the equation of the tangent to the given curve at the indicated point. So in this again, we start by getting the gradient function. The first thing is to get the gradient function, whereby we have the dy all over the dx, which is equal to, we differentiate this, 3 times the coefficient of x, which is 1, so we have 3x, 3 we subtract 1, then plus, we have 2 multiplied by the coefficient of x, which is 1, we have 2x, 2 minus 1, then the derivative of a constant is 0, so plus 0. So our dy dx will be 3x raised to power 2 plus 2x, 2 minus 1 is 1 raised to power 1. So that's what we have as the gradient function. Then we calculate the gradient at the point 1, 3. So we come and get the the gradient at the point 1, 3. So we have our x here, our y there. And therefore, our gradient dy all over dx will be equal to 3. We have our x, which is 1. So we have 1 squared plus 2, and our x is 1. So we are going to have this again. This is 1, 3 plus 2, and our gradient is 5. So our gradient is 5. So when we have our gradient, now we can be able to calculate the equation of the tangent. So we have the gradient m, which is 5, and we have the points 1, 3. So we also get another imaginary point, because we have said that when we have the point, let's say the point is here and the point here is maybe 1, 3, and we have the tangent, we also need to get another point. We can call this point xy. And we know that the gradient of this tangent, the gradient is 5. So we have another point xy. So, and we know that m is equal to change in y all over the change in x. Our m is 5, a whole number is always over 1, is equal to change in y, so we have y minus 3, or you can, whichever sign you start with, because this is also y, you can say 3 minus y, all over 1 minus x, or y minus 3, all over x minus 1. So we have y minus 3, all over x minus 1. Again, we come and close multiply. So when we close multiply here, we'll have 5. We are multiplying by x minus 1 is equal to 1. We are multiplying by y minus 3. So we end up getting, we open the bracket, we get 5x minus 5 is equal to y minus 3. So that is the equation. We can write it in the form y is equal to mx plus c. So in this case, we are going to say, therefore, y minus 3 is equal to 5x minus 5. So our y will be equal to 5x minus 5. Then we take 3 to the other side, which will be plus 3. So our y is equal to 5x minus 2. And this is the equation of the tangent. Equation of the tangent. And we can see clearly from this, our gradient m is 5, which is our gradient here. So this will be the equation of the tangent. I repeat, get the gradient function, because the gradient function will give you now the gradient at that point. So you get the gradient. Then after getting the gradient, you have another imaginary point, x, y, because that's the coordinate. That's how we write the coordinate, x, y. Then after that, gradient is change in y over change in x. So we have the gradient, which is equal to change in y, change in x. You close multiply and then get the equation of the tangent. Lastly, the last example on the equations of tangents to a curve. Lastly, so in our case here, we have been told to find the equation of the tangent to the given curve at the indicated point. So we can call this A, so that we can have B. So B, we have been given the equation y is equal to x cubed plus 3x squared minus 3. And the point here is x is equal to 2. So we have not been given the coordinate. We have been given the value of x. X is equal to 2. So the first thing, as we have said here, we need to first get the gradient function. We start with getting the gradient function, which is dy all over dx. So we have it as 3 times the coefficient, which is 1. We have 3x. Then we have 3 minus 1 plus we have 2 multiplied by the coefficient of x. The coefficient of x here is 3, so it is 2 times 3, which is 6. Then we have x, then the power minus 1. Then the derivative of a constant is 0. So we can even put here plus 0. So we end up getting 3x squared plus 6x raised to power 1, which we can write as 6x. Then after that, we need now to come and get the gradient when x is 2. The gradient at the point where x is equal to 2. So our dy all over dx, which is our gradient, will be 3. Our x is 2, so we come and put 2 squared, then plus 6. Our x is 2. So we are multiplying 6 by x, 6 by 2, because the x is 2. So we end up getting, this is 4 times 3. We have 12 plus 6 times 2, which is 12. So our gradient will be equal to 24. That is the gradient. So we have the gradient, which is 24. Then after that, we now come and say we have the gradient as 24. We do not have the point. We only have the point x, which is equal to 2. So we need to get the value of y so that we can get the point and then we take the imaginary point x, y. So what we have, we only have for x, which is 2, but we need to calculate for y. So we are going to come back to our equation, the equation of the curve, so that we can get the value of y. We simply come and say our equation is y is equal to x cubed plus we have 3x squared minus 3. And we have the point x is equal to 2. So we want to get the value, we want to get y when x is equal to 2, so that we can get that coordinate. So we simply come and say our y will be equal to x cubed, which is 2 cubed, plus 3, our x is 2 squared, minus 3. We get the value of y. So we'll have here 2 raised to power 3, that is 2 times 2, 4, 4 times 2, we have 8, then plus 4, which is 12, minus 3. So we have 8 plus 12, which is 20, minus 3, we have 17, meaning that the value of y is 17, and therefore the coordinate will be x is 2 and y is 17. And then we have an imaginary point x, y, and the gradient is equal to 24. So we can now be able to get the equation of this line, that is the equation of the tangent. So we are going to have, we know gradient is equal to change in y all over the change in x, and therefore our gradient is 24. Our change in y, we have y minus 17, y minus 17 divided by x minus 2, x minus 2. This is over 1, so we cross multiply this. So we are going to have 24 into bracket x minus 2 is equal to 1 into bracket y minus 17. Then we open the brackets, so we are going to have 24x minus 2 times 24, that is 48, is equal to y minus 17. So we can write it in the form y is equal to mx plus c. So we start here, y minus 17 is equal to 24x minus 48. So we are going to have y is equal to 24x minus 48 plus, we take 17 to the other side, it becomes plus 17. So here we are going to have our y is equal to 24x. Here when we have 17, we'll have therefore minus 31. And this is the equation of the tangent. And you can see also clearly from this, the equation of a straight line y is equal to mx plus c. So our m is 24, which again is our gradient. That's what we got as the gradient. So the equation of the tangent will be y is equal to 24x minus 31. And as we have seen, a tangent is a straight line. And therefore, the equation that we are getting is an equation of a straight line. So that's how we calculate the equations of tangents to a curve. So the first thing, get the gradient function when we are given the equation of the curve, get the gradient function. After getting the gradient function, get the gradient at the point x is equal to whatever you've been given. Like in this case, our x is 2, so you get the gradient. After getting the gradient, we have the gradient. You also need an imaginary point and the point that is given on that line, that is the tangent. So if you have not been given the value of y, you can use the equation and substitute the values of x to get the value of y. So get y when x in our case is 2. After getting y, now you have the point xy, which is now the coordinate and the imaginary coordinate. Then you can calculate the gradient, which is change in y over change in x. From this, you can be able now to get the equation of the tangent. So I'd like to give you an exercise on calculating the equations of tangents. to a curve, the equation of a tangent to a curve. So in this we've just looked at the equation of tangent. So find the following exercise. Ensure that you do the following. Number 1, find the equation. Find the equation of the tangent. Find the equation of the tangent to the given curve at the indicated point. You find the equation at this indicated point. So in the first one, A, we have y is equal to x raised to power 4 minus 3x squared plus 2x, and the point is x is equal to 1. Then B, we have y is equal to x cubed plus 6x squared minus 3x plus 1 at the point x is equal to 0. So remember, you have to find the coordinates. Then number C, you have y is equal to x cubed plus 3x squared minus 7, and the point is 1, 2. That is the point that you have been given. Then finally, in this part, number D, the equation is y is equal to x cubed minus 2x minus 1, and the point is 1, negative 2. And finally, question number 2. Question number 2 on equation of tangents. You are told question number 2, find the equation. Find the equation of the tangent. Find the equation of the tangent to the curve. And the curve is y is equal to x cubed at the point 1, 1. So ensure that you do those questions so that during the next lesson we'll be looking at now the equations of normals to a curve. Thank you for being a good student.